All right, so if you haven't had the opportunity, let's get it set up. Mark your diagram appropriately. All right, mark it up for you. In the givens, what does it say ABCD is? It's a, okay, quadrilateral. That's it. You have no properties. Doesn't say parallelogram, just says quadrilateral. So don't start popping all these properties at me. Doesn't exist. It's just a quadrilateral. Look at your proof statement. Prove two segments are equal. We've done this over and over, right? Next thing I'm going to say, those segments aren't equal until what are equal? Or what are congruent? The triangles. So let's find a pair of triangles that have FG and EG in it. FG and EG. I think there's only one pair, right? So let's get triangle BGE congruent to FGD. If you can get those congruent, those segments are congruent by Cpctc. Easier said than done. Forget about any of the givens. What do you know right away is congruent? Forget about the givens. What do you see up there is right away in those two triangles that have to be congruent? We can at least write it down, maybe get a point out of 6. Oh, 11. Yep, I got my vertical angles congruent. Don't need any givens for that. So angle BGE congruent to angle FGD. Vertical angles are congruent. If you want to keep track of your work, remember I always used to put an A there that says, hey, you have at least an angle now. So 2 more pairs to go. 2 more pairs to go. And this is where it's going to get tough now. Okay, everyone can do the vertical angles. I have total faith in that. So maybe you'll get a point out of 6, but we need more than that, right? Come on, we need all 6. So now I got to figure out where the other sides or angles are going to come from. Now, all this, they told you for a reason. Use it. Use it. They told you that for a reason. They're never going to give you a given that you're not going to use. So why did they give us all that information? Well, let's first start with these 2 angles being congruent. Identify those angles. What do we call those? Those are what type of angles? What type of angles are those called there? 1, George? Darn right. Let's go. Let's go. Alternate interior. Nobody else is getting that, by the way. All right. That's status right there, VIP. These are alternate interior. If they're congruent, name the lines that have to be parallel then. 5, Jackson, what lines are parallel then if these 2 are the alternate interior?
B, A, and C.
Got to be parallel. Congruent, alternate, interior angles imply parallel lines. Why is that so great that the parallel? Molly!
It makes A, B, C, D a parallelogram.
Hey, remember in the givens, these were congruent, and now Jackson just tells us these are parallel. If you have one pair of parallel sides parallel and congruent, you have a parallelogram. So we just turned that quadrilateral into a parallelogram. ABCD is a parallelogram. We used to call this special case, but you guys know you can't write special case in your reasons. One pair of opposite sides, congruent and parallel, imply I have a parallelogram. So great job by all of you. You turn that into a parallelogram. Why is that so helpful for us? Now you have properties. Use some properties of a parallelogram that may help us get angles or sides now. Oh, can I just say something and you tell me why I'm 100% wrong, please? Wrong. Oh, it's a parallelogram. Diagonals bisect each other. These are equal. These are equal. I'm done. Why not? Why am I totally wrong there saying diagonals bisect each other here? Romeo.
Because they don't start from the vertices.
FE is not even a diagonal. So I can't use it. Don't give me that garbage. FE is not a diagonal. All right, anybody see any parallelogram properties that might help me get sides or angles in these two triangles? You know it's a parallelogram now. Any properties now that may help us? Via.
We can still use the alternate interior.
But now for what sides though?
Now for like we're trying to prove like Hamas, E, B, G.
Okay, yeah. I got you. So you're saying EBG and GDF, right?
Yep.
But I can't say that until I have parallel lines.
If you have parallel lines.
Not those though don't lead to these. Look, you see the ones you're giving me here? They're not formed by these here, are they? What lines are they formed by? Which parallel lines form those congruent angles you were just talking about? BC and AD. So I need to say they're parallel. BC parallel to AD. Do you see why?
Yeah.
Okay. Not BA and CD don't form those. So parallelogram. This is a long one, 6-pointer. It's worth it. Parallelogram implies opposite sides parallel. Now you could say the alternate interior angles are congruent. Good. So now I can say EBG, GDF. Say that again? All right, hold on. Let me get this down. Angle. Everyone good so far? I turned it into a parallelogram. Opposite sides are parallel, which means alternate interior angles are congruent. So EBG, congruent to GDF. Anybody remember how I start this reason? Parallel lines imply alternate interior angles congruent. And that gives me a second A. That gives me a second A in those two triangles. All right, now look, let's start thinking here. Working smarter, not harder. Is it going to be another angle or a side I'm looking for now? It's got to be. Angle, never been away all year. So it's definitely got to be a side in these two triangles I'm looking for. I'm not interested in the other pair of angles. It's got to be a side somewhere. And I don't care where that side is. It can be in between. It doesn't have to be in between. Both are going to be ways to prove them congruent. How else could I get a side in these two triangles without no diagonals bisect each other? We went over that. You got something, Via?
Yeah, you can subtract AD and AF along with because we're going to BC minus CB.
Okay, it is going to be subtraction, but not yet. What do I still need to tell you about BC and AD before I subtract? I need to tell you they're congruent. Everyone see where we're going now? Yes, these sides are parallel and they're also congruent, and I can do something we used to call, subtraction from there. All right, so we got a lot more steps to go here. So first say BC and AD congruent. Parallelogram implies opposite sides congruent. Now you can do subtraction. And what did we always write after subtraction? Substitution. Go. I don't have to write this down for you. Tell me what you're subtracting, right? BC minus EC equals AD minus AF. And then, yes, right underneath, the substitution. And then I'm going to ask somebody why these triangles are congruent. What method? Whew. Got real quick, huh? 6 points. That's why. Everyone up? We're getting to the substitute. You got the substitution written? Okay, what's the method now? I could say these two triangles are congruent. Look at it, look at it. 4. One job. 7. Thank you, Luke. 1, George, come on. Savage. Angle, side. And then what's the reason, we didn't say it, but what's the reason FG and EG are going to be congruent after angle, side? 11? Cpctc. Alrighty. Ooh, wow. Did anybody do, there is another way you could have done it, I think. Yeah. Relax. I'll do the teaching. Is everyone all right here? I think the other way you could have done it without mentioning it was a parallelogram. Everyone see these two big triangles on top? We had this already. We had this already. BD's reflexive. What do I know about those two? What do I know about the two big triangles? Side, angle, side, they're congruent. And then you could have said Cpctc, these two are equal, these two, and then done your subtraction. So that's another way around it. Okay, you could have gotten the big two congruent to get some parts. All right, good. Any questions, comments, concerns? Okay, we're done with that. Go to August 2019 and take a peek at 33 now. August 2019, number 33. They just get tougher here, I think. Hopefully we're planning on coming to a couple of review sessions when I announce them next week. We got next Saturday and next Monday. I'm going to have a big outside of class review sessions anyway. Next Saturday and next Monday. I'll announce it next week and put it on Classroom. Yep. And then anytime, also I'm not going to post it, but anytime school's in session and you don't have an exam, I'll be here if you want to stop in and review. Okay, so there's not going to be like set times that come in. If it's Monday through Friday, I'll be here during the regular school day, whether you have an exam or not. All right, ready for 33? Whew, not much. All right, not much. Look at the givens. Here's a pair of triangles congruent. Get another pair congruent for me. Whew. All right, ready? Try to do this. Well, right away, can anybody write anything down here? So you can get at least a point here. I got to stop talking like that. Get at least a point. We're better than that. We just don't get points. 6, anything we can write down here right away? Just look at the two triangles here, Luke. Forget about the givens. What can you tell me already that are congruent? You all right? These two triangles we're trying to prove congruent.
Yeah.
What do you already know is congruent without knowing any given?
Vertical.
Okay, there you go. You all right? Little freeze there. AFD congruent to EFC. Vertical angles are congruent. All right, well, we got a pair of angles. Congratulations, everybody. Now here comes the tough part. Where's everything else, right? Where's everything else? Now let's go to the given. Triangle ABE congruent to triangle CBD. Remember, any sides or angles in those triangles are congruent already by Cpctc. So can you find any angles or sides in these two that are shared with these two? Can you find anything? Because any sides or angles in these two given triangles are congruent already. Is there anything that overlaps or is common between these two triangles as far as angles or sides go? Look deep here, look deep. Any angles or sides that are in common here? You can find it. Come on, dig deep. Jackson, 5. Look at the 2. Ready? Let me highlight. It's probably easier if I have this purple one, and then I have ABE. Any full angles or sides you see that are in common? Doesn't look like sides here. Those aren't in the smaller one, but is there an angle in there that's a common in both? Yep. I got it. Everyone's got A, and let me do it for the other one. You tell me the other one now. A, and then CBD here. I got A and C congruent. Everyone see that? A and C are congruent. Anybody know the reason? Cpctc, yeah. Because they were congruent. They were part of the congruent triangles. Good. All right, this third one's got to be a what, though? A side, right? It's not going to be the other angle. It's got to be a side. This is where it's going to get a little tougher now. How can I find a side? All right, let me give you a little push here. Let me get a little push. Side AB. Side AB is congruent to what in the other triangle? Side AB is congruent to side. Okay. Agreed, right? Those two are congruent, the ones I just highlighted in blue by Cpctc. Keep looking at those triangles. Let's see. Side DB. Side DB is congruent to what in the other triangle? BE. What can I do with those two pairs of sides to get a side in the triangles I'm looking for? Subtraction. Everyone see that? That was a tough one. Subtraction. All right, so let's write down the Cpctc first. And look, hey, while we're here, if you want to write it in step 3, you can. All right, because it uses Cpctc. I am not, though. I'm going to write it separately. So we said DB was congruent to BE. And then we also said AB was congruent to BC by Cpctc. Both those sides are in the big triangle that we already know are congruent. And then what'd you guys tell me to do to them to get it to a side in the smaller ones? Okay, go ahead, subtract them. Subtract, substitute. And then I'll ask somebody once again, what's the method of proving the triangle's congruent? So subtraction, substitution. Bless her. 13, when you're ready, let me know why these two are congruent.
Angle, side.
Great job, Lucy. Angle, side. Yep. Questions from you guys? Going? All right, so those were two statements, reasons, proofs. All right, two statements, reasons, proofs that involve triangles. Another type of proof that's not statements, reasons that you might see, it's very common, could easily see it in a couple Tuesdays from now, is the ones where we graph them. All right, and we have to use distance, midpoint, slope to prove what they're asking to. So go ahead right now. I'll give you guys a second. I think it's on the following. The graph isn't on the first page. I think it's on the next page. So go ahead and graph triangle ABC. Sorry, it's the last problem. It's part 4.1. So instead of seeing a statements, reasons part 4, you might see what's called a coordinate geometry part 4, where you got to graph it, use distance, midpoint, and slope to prove what they're asking. Doing all right there, baby? Any questions? Okay. Take your time. All right, ready to go? Got a graph. First part, prove it's isosceles. What do you know about an isosceles triangle? How many congruent sides?
2.
Okay, so this is why it's good to graph too. Okay, so we could save ourselves time. I don't want to waste my time and do all 3 sides. Can we pretty much tell which are going to be the 2 sides that are going to come out to be the same length? What do we think? Which 2 sides? AB and BC. Okay, so that's the advantage to graphing. At least we could tell, yeah, it's probably going to be AB and BC. How do I show they're equal now? Distance formula. Okay, I got to use distance formula now. So again, the setup to it, this is not statements, reasons, but you still have to number your steps. So step 1, we're going to find the distance of AB, and we're going to find the distance of BC. And cross our fingers, hopefully our algebra is good and they come out to be the same. All right, distance formula. I know it's on your cold hard fact sheet, and I should be telling you to look it up, but I want to keep going here. x2 minus x1 squared plus y2 minus y1 squared. And that should be going on your geometry regions formulas to know whenever you can. Number 1 right on there, distance. So plug in your x and y values. Go ahead and plug in your x and y values. You got plenty of room there. And I'll let you guys do that. Hopefully you're squaring 1 and 6, or -1 and -6, some type of versions of those. But you should at least be squaring 1s and 6s, whether they're positive or negative. and getting out the square root of 37. How's that look? Square root of 37. No need to break it down or try to. Don't be a hero. That's good enough. And go ahead and do the same thing for BC. Take your x's, subtract them. Take your y's, subtract them. $37 again. And ask me if you can't get the 37, ask me. We all right? Okay, seconds now. Okay, step 1, I showed the distances. Step 2, what did you just learn from using the distances? We need to learn, yes, AB is congruent to BC because distances are equal. Step 3, what do you now know? Alrighty. Triangle ABC is isosceles because, that's fine, yeah. I'm not looking for anything specific. It has 2 congruent sides. 2 congruent sides imply an isosceles triangle. Well, get the point across. It's got 2 congruent sides. All right, good. So we got that part down. Questions? Now let's get a little more complicated. Where is point D on this graph that makes ABCD a square? So where do I put point D so this would turn into a square? Thank you. We know it's got to be somewhere over here, right? Because it's got to go in order. A, B, C, D. Yep. Okay, where exactly, though? And how can I do this mathematically? Square. It's square. AB, and wherever D is going to be, AB and CD have to be what to each other? It's a square. Congruent and parallel to each other. Everyone agrees. So if they're going to be parallel to each other, A, B, and C, wherever D is, have to have the same. Okay, that's how we're doing this. So everyone right now with me, start from B and go to A and do rise over run. How many down and over do I need to go from B to A? Down how many and over how many from B to A? 2?
Down 1.
Yep.
And then over 6.
So guess what I'm going to do from point C? Where am I going to go up from point C? Down 1 over 1, 2, 3, 4, 5. There it is. They have to have the same slope. They have to. Could I have done the same thing from B to C and done it from point A? Yeah, I could have. It's another way of doing it. Sure. So what's point D here? What is that coordinate? Just make sure we can read graphs correctly. 18, what's that coordinate? 0, -4. Everyone all right how I got there? Just using slopes. I don't know really how else you could get there, but. All right, then final piece. Now prove to me it's a square. And this is where I need to make sure you guys are good here. How do you show it's a square? Because I think some of you guys would do it one way, but it's not going to be enough info. How do you show this is a square? Any thoughts? Throw them out. Scott? Okay, that's what I would figure most of you guys would do. You would do, we already did that, by the way, so why not? You do that and you say it's a square. That's not good enough. You're getting there. It's fine, but I need more because right now, it's just a rhombus. That's a rhombus right here by proving all four sides equal. I need a little bit extra that makes that rhombus over the hill and into a square. Molly? I need a right angle somewhere. All right, so yes, let's do this, and then we're going to prove it has a right angle. All right, that makes it into a square. No need to do AB and BC again. We already did it. So now, go ahead and do AD and CD, the distances. All right, so I can get all four sides. You don't need to repeat something you've already done. And then we'll talk about how in the world do I get a right angle. Also, square root of 37. All good? And then we should probably say now what about all four sides? AD congruent to CD, congruent to BA, congruent to BC because all four sides are equal. I mean, all distances are equal. How do I get that right angle? No more distances. Luke, no more distances.
Don't you like find out they're perpendicular to each other because their slopes?
Slopes should be what? Not equal, but what's that term, Scott? Negative reciprocal. So here's what we're going to do. Slope, and it doesn't matter where. I just put a right angle at B, so I'll stick there. Slope of BC equals this. Slope of BA. And I'm just picking these two sides, everyone. You could have picked any two adjacent sides and done this. If you want to use the formula, remember it's y2 minus y1 over x2 minus x1, or count it on the graph, rise over run. Either way is fine. Either way is accepted. You can do rise over run or this slope formula. Plug it in your y's over your x's. So BC, I think, is 1 over 6. And BA was, no, I got to reverse that. BC is 6 over 1. So 6. And then BA is negative 1 over 6. And what do you notice about 6 and negative 1, 6? Makes them perpendicular, yep. BC perpendicular to BA because slopes are negative reciprocals. And what can I say about angle B? Angle B is a right angle. How do you know it's a right angle? Perpendicular lines form right angles. And then, guess what we have on our hands now? Finally, ABCD is a square. I'm interested to see what's your reasoning here. It's got to be detailed. How do we know it's a square? What did we just prove in all 9 steps here? Okay, let's start there because all sides congruent, but I can't stop there, right? That's just a rhombus. And it has one right angle. There you go. A lot of writing, but easily could see one of these on there. Questions? All right, so I want to at least go through all the different proofs that we could possibly see. There's one other type we have to go over Monday or Tuesday as well. Any questions about the exam? My hope is you guys, I get it. It's a pretty stressful time right now because what do you guys have? 4 or 5 exams, including this one? Okay. I'm never going to say one's more important than the other. All I'm going to suggest is plan it out. Plan your studying out. Okay, on this day, I'm going to study for this amount of time, and then go to this. I don't know if going on a 3-day bender on the 18th, 19th, and 20th for math is the best idea. Okay, I don't know if that's the best idea, is just start your studying then and just going on a 3-day crazy study session. You're going to be exhausted. All right, good enough. At this point in the year, with 2 days left, I'm not going to suggest problems to try.